For 60 years, we've been waiting, we've been listening, we've been looking up at the stars, convinced that somewhere out there, someone or something must be listening to us. But after decades of scanning, what do we have? Silence. In over 10 million star systems, with 40 of the best radio telescopes humanity has ever built, there hasn't been a single sign of intelligent life. No artificial signals, not one. It's a deafening silence. Let me put it into perspective. Imagine this number, 0.00001%. This is the probability that in a galaxy containing 400 billion stars, only one technological civilization could emerge in 13.8 billion years of time. Statistically, this is nearly impossible. Yet, the silence remains. It's real. It's undeniable. For decades, we were told that the silence was merely a result of us not looking long enough, that the galaxy is too vast, radio signals are too weak, and we just needed more patience. This theory was accepted, even comforting. The universe is so vast, scientists said, we just haven't found the right signal yet. And so, the silence continued. For 60 years, we assumed that our silence was nothing but an inconvenience, a mere gap in data. But what if we've been wrong all along? In November 2024, a breakthrough happened. A team of researchers from Beijing Normal University ran the numbers again. They took a fresh look at every probability, reanalyzing every variable in the Drake equation, one of the key models scientists use to estimate the number of extraterrestrial civilizations. They used conservative, optimistic, and even pessimistic estimates, and the results were astonishing. The silence, they concluded, isn't just an absence of evidence, it is evidence. If the galaxy is full of stars, and the time span is long enough 13.8 billion years, in fact, then silence is no longer a coincidence. It points to something far more profound. If you're familiar with this channel, you know that we dig into anomalies, strange phenomena that challenge everything we think we know about the universe. From the oddities of the moon's tidal lock to the mysterious trajectory of 3I Atlas, we've been following these strange signals in space. But what has been unfolding around us is even stranger, an anomaly that no one has been able to explain away. The Fermi Paradox. But here's the kicker. It's no longer a paradox, it's a pattern, a deliberate one. The issue is, we've been broadcasting into space for 120 years, radio waves, TV signals, radar, all of it. For the last century, every bit of communication we've made has been leaking out into space at the speed of light. That's 120 years of broadcasts traveling outward. So far, 184 star systems have heard us. Some of those systems received our signals decades ago, some even a century ago. There's been more than enough time for a response. A return signal, anything, but for all that time, the silence has remained absolute. No one has responded. Not a single beep, chirp, or whisper in the void. Now, let's do some simple math. If even 1% of stars in the galaxy have planets capable of supporting life, and even 1% of those develop life, and even 1% of those evolve intelligent beings capable of advanced technology, that still means we should be hearing from at least 18 other civilizations. That's 18 different signals coming from somewhere in the galaxy. But guess what? We haven't heard anything. Not even one. For 70 years, scientists came up with every possible explanation. Maybe aliens are using a communication method we just don't know about yet. Maybe they're too far away. Or maybe life is so rare that we are truly alone. But all of these theories, every single one, assumed one thing, that silence is neutral, that it's just a matter of time until we find them. But what if we've been wrong about that assumption? This was all upended in 2024. A new study of SETI data revealed something startling. For 64 years, SETI has been scanning the sky, 10 million star systems have been surveyed, and in all that time, we've not only found no signals, we haven't even found any candidates, no false alarms, nothing. When you're looking for something as rare as extraterrestrial life, you expect some noise, some glitches, something. But since the famous wow signal in 1977, nothing, absolutely nothing. And this is where the numbers get chilling. Out of the 184 star systems that have already detected us, if even one of them has life, that's one potential response. If even one system has technology, we should have heard from them by now, but we haven't. Which leaves us with three possibilities. None of those systems have life. This would make Earth an extremely rare anomaly. They have life, but no technology. Maybe Earth is the only planet where intelligent life emerged, but that raises another question. Why would life evolve intelligence on Earth, but nowhere else in the nearby systems? They have technology, they heard us, and they chose not to respond. This is where things get really unsettling. For 70 years, scientists have proposed hundreds of explanations to explain the silence, but despite these attempts, none of them fully address the heart of the issue. The silence isn't just a void, it's a signal in itself. After all, silence is not just a lack of sound, it's the absence of something that should exist. We've been broadcasting signals into space since 1900, and every single broadcast has carried our presence out into the galaxy. Yet, the response? Zero. For over a century, there has been nothing. If you're still skeptical, let's break down the numbers again. We have 184 star systems that have heard us already. And in all this time, decades, even centuries, those systems have had ample time to send a message, to make contact, to reach out. But they haven't. Silence. This is more than just an odd coincidence. It's a pattern that shouldn't exist. We're seeing something that doesn't line up with our expectations. If even 1% of those star systems harbor life, then we should be looking at 18 potential civilizations capable of responding. But the response we've gotten? None. Not one. The question then becomes, why? When we combine these statistics with the data from SETI's decades of work, a chilling realization begins to emerge. SETI, which has been scanning the skies for over 60 years, has surveyed 10 million star systems. In all that time, no signals have been detected. Not even a false alarm. Not a single one. And here's the real kicker. In 1977, SETI picked up the famous wow signal, a 7-2-second burst of what looked like an artificial signal coming from the Sagittarius constellation. It was a brief and exciting moment, but after further investigation, it was determined to be a comet. So, what has happened since then? Nothing. Absolutely nothing. Now, think about the implications of that. We have not just failed to detect the extraterrestrial life, we've failed to find even a hint of it. No false positives, no misreadings, just pure, unbroken silence. This isn't just statistically improbable, it's practically impossible. And when we look at the 184 star systems that have detected us, the silence becomes even more perplexing. The data says it all. If even 1% of those systems have life, that's 18 civilizations potentially capable of responding to us. But still, silence. And that leads us to a terrifying conclusion. It's not that they can't respond, it's that they've chosen not to. In 2023, a team of researchers from the University of Tokyo revisited an old idea, the dark forest hypothesis, which proposes a chilling answer to the question of why extraterrestrial civilizations remain silent. The dark forest theory first popularized by Chinese author Liu Cixin in his book The Three-Body Problem, frames the universe as a vast, dark forest. In this forest, every civilization is a hunter, and each hunter is hiding in the trees, trying to avoid detection. The logic goes like this. You can't know whether the other hunters are friendly or hostile. The only thing you know for sure is that if you reveal your location to the wrong hunter, you could be killed. In this context, silence isn't just an absence of communication, it's a survival strategy. Every civilization in the galaxy, if they're following the same logic, is hiding in the dark forest, staying silent in order to protect themselves. And that's where the real danger lies, because if a civilization has the capability to travel across stars and make contact, they also have the technology to eliminate other civilizations. A simple asteroid, accelerated to 10% the speed of light, could wipe out a planet with ease. The energy required to sterilize a planet from another star system is surprisingly small, and a civilization capable of interstellar travel is likely capable of this form of destruction. So, in this framework, silence isn't just a choice, it's a matter of life and death. The only way to avoid becoming a target is to stay hidden, to avoid drawing attention to yourself. The only civilizations that thrive are the ones that stay silent. And the worst part? The math works. Researchers who modeled thousands of civilizations found that the only civilizations that survived over long periods were the ones that kept quiet. Those that made noise, whether transmitting signals or actively broadcasting their presence, were wiped out. This shifts the whole understanding of why we haven't made contact with extraterrestrials. Silence isn't random, it's deliberate. The galaxy isn't empty, it's hiding. And the more we look at the data, the more we see that we may have been wrong about everything we thought we knew. Now, let's take a step back and think about the most disturbing possibility. What if silence is not an anomaly, but a survival strategy? In 2023, researchers at the University of Tokyo revisited an old but powerful idea, the dark forest hypothesis, first introduced in the science fiction novel The Three-Body Problem by Liu Cixin. The theory is chilling, yet plausible, and it provides a potential answer to the question that has haunted humanity for centuries. Why haven't we heard from extraterrestrial civilizations? Imagine the galaxy as a vast, dark forest, with civilizations scattered like hunters hiding in the trees. You don't know who else is out there, or whether they're friendly or hostile. The only certainty is that if you make yourself known, you run the risk of being destroyed. This is the essence of the dark forest hypothesis. In such a scenario, the most rational choice is to stay quiet, completely silent, because revealing your location to the wrong civilization could mean annihilation. It's a terrifying thought, but the more you look at the numbers and the theories behind them, the more it starts to make sense. The galaxy is full of potential life, but most of it remains hidden, silent, and out of reach. The civilizations that choose to remain quiet have the best chance of surviving. Those that broadcast their presence to the stars, hoping for contact, may not survive long enough to make that first contact. The mathematics behind this hypothesis is rooted in game theory and evolutionary biology. When you run simulations of multiple civilizations interacting over billions of years, the ones that transmit without caution tend to go extinct first. In fact, the only civilizations that survive long-term in these models are the ones that keep their existence hidden, blending into the vastness of space, never revealing their position. After running these simulations, the researchers found that in every scenario, the civilizations that stayed silent were the last ones standing. The civilizations that made noise by transmitting signals into space, for example, were the first to be destroyed. The basic principle here is survival. If even 1% of civilizations are hostile, or if interstellar travel is possible, the risk of detection outweighs any potential benefits of contact. Silence becomes the only viable strategy. So, this is where the math meets the terrifying reality. If silence is a survival strategy, then the Fermi Paradox is no longer a mystery. It's a pattern, one that's been unfolding across the galaxy for billions of years. Silence isn't just a lack of communication, it's deliberate, and the more we study the data, the clearer it becomes that the civilizations that speak up, that make their presence known, risk annihilation. But let's take a step further. If we're not alone, and if civilizations really are staying silent for their own protection, then why are we still broadcasting? We've been sending signals into space for over 120 years now. Every radio wave, every TV signal, every radar pulse has been leaking out into space at the speed of light. Our presence is no longer a secret. There's a bubble of human noise expanding through the galaxy, 120 light years in radius. And within this bubble are 184 star systems that have already heard us. Yet, in all that time, not a single response. Now, let's break down the implications. If even 1% of civilizations in those 184 star systems had developed intelligence, that's 18 civilizations. If even one of those civilizations wanted to respond, we would have heard something by now. But we haven't. This silence points to one of two possibilities. Either those civilizations don't exist, or they have chosen not to respond. And that brings us back to the dark forest theory. Maybe they're all hiding, just as we should be. This realization takes us to the next unsettling question. Why haven't we stopped broadcasting? Why hasn't the scientific community, those who understand the risks, called for a halt to active SETI? Active SETI, as it's called, refers to our attempts to send messages to other star systems. In 1974, we sent the famous Arecibo message toward the M13 cluster of stars. In 2017, we sent another message toward a star 12 light years away. But what if continuing this practice is a mistake? What if by broadcasting we're inviting danger into our solar system? There's a growing debate about this very issue. Some argue that if no one makes contact, then the galaxy will remain silent forever. Someone has to go first, they say. But others, including some of the most prominent scientists in the world, believe that we are playing with fire. As renowned physicist Stephen Hawking warned in 2010, reaching out to extraterrestrials could be catastrophic. He compared it to the first meeting between Europeans and Native Americans. The meeting didn't go well for the natives. In fact, it wiped them out. Why? Because the Europeans had more advanced technology, more resources, and less compassion. What if the same applies to us? What if a civilization capable of reaching Earth has no interest in negotiating with us? What if they see us as a resource to exploit, a threat to eliminate, or simply as an obstacle in their way? The dark forest hypothesis forces us to confront these difficult questions. It suggests that if we continue to broadcast, we're taking a massive risk. The galaxy may not be empty. It may be full of civilizations that have learned the hard way that silence is the only way to survive. And the more we send signals into space, the more likely it is that someone or something will eventually take notice. And if they don't like what they see, it could be the end of us. As we explore the dark forest hypothesis, the chilling question arises: why are we still broadcasting? For over 120 years, humanity has been sending signals into space. TV broadcasts, radio waves, radar pings, all leaking out into the universe at the speed of light. This constant broadcast of human activity has created a growing bubble of noise, expanding outward 120 light years across. Right now, that bubble encompasses 184 star systems that have already heard us. These civilizations have had decades, even centuries, to respond. And yet, the silence persists. Let's consider the implications of this. If only 1% of stars have planets with life, that still gives us 18 civilizations scattered across the galaxy. And yet, despite having the opportunity, not a single one has reached out to us. In the context of the dark forest theory, this silence is more than just an absence of contact. It's a survival mechanism. Every broadcast we make into space is a risk, one that we may not fully understand. Here's the hard truth. If silence is the key to survival in the galaxy, then we might be making a fatal mistake by continuing to broadcast our presence. Every time we send a signal into space, we might as well be painting a target on Earth. This is where the theory of evolutionary game theory becomes relevant. If any civilization has the power to travel across stars and detect our signals, they also have the technological capability to destroy us. This could be done with something as simple as an asteroid accelerated to 10% of the speed of light. That's enough to wipe out a planet. And the civilizations that send signals into space without considering the consequences may be obliterated. As unsettling as it is, the mathematics behind this theory works. Evolutionary simulations show that the only civilizations that survive are those that stay hidden, those that don't broadcast their existence to the universe. Any civilization that takes the risk of making itself known is likely to be destroyed by another civilization with more advanced technology. And right now, we are broadcasting our presence loudly. The question then becomes, should we stop? Should we cease broadcasting and join the ranks of the silent civilizations, hoping that we are too small to notice? Or is it too late to turn back? Now that we've established the risks involved in broadcasting, let's take a closer look at the 184 star systems that have already detected us. These systems are the first to have heard Earth's radio waves, television broadcasts, and radar signals. We've been broadcasting into space for over a century, and yet we have received no response. Not a single message, no signal, no communication. This silence is not just perplexing, it's troubling. Here's what the numbers tell us. Over 120 years, Earth has sent out signals in all directions. Every time we broadcast, those signals travel outward at the speed of light, reaching more and more star systems. As of today, 184 systems have already heard us. But here's the thing. They've had plenty of time to respond. Some of these systems have heard our signals for decades. Some of them, perhaps even a century. There's been more than enough time for them to send a signal back, and yet not a single one has. If even one of these 184 systems harbors life, that should be at least one civilization that could potentially reach out. If even one of them has developed technology, that's one civilization that could respond. But no response has come. So why is that? The dark forest hypothesis provides one possible explanation. If those systems have detected us, it's possible they've chosen not to respond. And if that's true, then the silence isn't random, it's intentional. These civilizations may be hiding, just as we should be. The silence becomes less of a mystery and more of a deliberate strategy for survival. The growing silence across the galaxy raises an even more disturbing question. What do they know that we don't? Have they learned from their own history that revealing your location to the universe is too dangerous? Did they go through a phase of broadcasting only to learn that the risks of being detected outweigh the potential rewards? What happens when civilizations like ours send out signals into space and no one answers? Are we the last ones left to make the same mistake they did? As we consider the implications of the dark forest hypothesis and the possibility that silence is a survival strategy, we're left with a deeply unsettling reality. Silence may not be a permanent condition. It's a countdown. Every year, more civilizations in the galaxy are detecting us. Every year, the bubble of human noise expands, reaching more and more star systems. By 2050, 5,000 systems could have heard our signals. By 2100, that number could reach 10,000. The question is, what will happen when someone decides to respond? Right now, Earth is in a unique position. We've been broadcasting for over a century, and we've already attracted the attention of 184 star systems. But what if we're not alone in the galaxy? What if there are civilizations out there that have already gone through the same process that we are now experiencing, the process of making themselves known, only to find out too late that silence was the only way to survive? What if those civilizations chose to hide, just as the dark forest theory suggests? We can't take back the signals we've already sent, but we can decide what happens next. The question is whether we will choose to continue broadcasting and risk bringing the wrath of a hostile civilization upon us, or whether we will decide to go dark and stop transmitting, hiding in the safety of silence. It's a choice with high stakes. The wrong decision could lead to extinction. The right decision could mean our survival. The consequences of being wrong are absolute. But perhaps the scariest part of this whole dilemma is that we don't know what's true. We don't know whether the galaxy is empty, whether it's full of civilizations hiding, or whether we are being watched and tested by more advanced beings. And until we know, every broadcast we make could be a countdown to the moment when someone notices us and decides to act. As we reach the end of this analysis, I'll leave you with one final thought. The silence in the universe is not random. It's a pattern, and that pattern is a warning. Whether the silence is a test, a threat, or simply the emptiness of space, we need to understand it before it's too late. What do you think? Should we keep broadcasting or go dark? Is the silence a warning or just the result of an empty galaxy? Drop your thoughts below and let's continue this conversation. And if you want to explore other cosmic anomalies, check out the playlist on screen. Because no matter what the silence means, we'll keep looking at the data until we know the truth.